Okay, so we have this toy airplane. So I got this off the internet because I can't draw an airplane. And the air exerts a forward force of 10 newtons on the propeller of a 0.2 kilogram model airplane. All right, so we're being told, well, this doesn't really have a propeller. This is like a jet, whatever.
They're on the sides and the wings.
Yeah, there's the propeller right there. Okay. So anyway, the forward force on this airplane is 10 newtons. The acceleration of the plane is 2 meters per second squared. So let's write that down. A equals 2 meters per second squared. Positive. What does positive mean? To the right. You know, our sign convention is this. Plus, minus, plus, minus. All right. What is the magnitude of the resistive force exerted by the air on the airplane? All right, so the resistive force is going to be opposite the motion, so it's going to be back to the left. And let's just label that lowercase f for friction. Okay. To me, resistive force. Let's just call it friction. Okay, so we have forward force. Now, what about the vertical? So if this airplane's flying along, does mg act on the airplane? Yeah. The airplane has a weight, mg. And then for airplanes, does anybody know what you call the upward force? They call that a lift force, the force of lift. Now, for this problem, the y direction's not going to matter, right? The vertical direction's not going to matter because we're focusing on the x. We're focusing on the x direction. Okay, so summing the forces now, summing forces x, we have how many x forces? 2. We have the 10 Newton force to the right, and then our resistive force to the left. So when you sum these up, we have 10 newtons minus our frictional resistive force. What did we just do right here? We wrote an equation. We summed the forces in the x direction. Sum of the forces always equals ma, or that's an x acceleration. Now, look. To be complete here, we're not going to need this for this problem, but let's be complete. There's a lift force up. Airplanes, the reason they fly is there's a lift force minus mg. We summed the forces in the vertical. Sum of the forces always equals ma, or that's a y acceleration. But is this airplane accelerating vertically? Is it going like up or down? No, it's just flying along horizontally. So we can cross this y acceleration to 0. So what has to be true about the lift force? The lift force has to equal mg. It has to equal the weight of the airplane. Okay? All right, but let's solve the question. The question is, what's the resistive force, which is this lowercase f? All right, so lowercase, that f is going to be equal to 10 newtons minus ma when you rearrange the algebra. Okay, so 10 newtons minus, the mass of the airplane is 0.2, and then the acceleration is 2 meter per second squared. So that's going to be 0.4. So the resistive force is going to be about 9.6 newtons, which is the answer to the question. Okay. Hey man, what's the net force on the airplane? That's it doesn't ask for it, but how could you find out the net force? So we now know that this resistive force is 9.6. So what is the net force? So the vertical forces are canceling. The lift force and mg, what are those two forces doing? They're canceling. Okay. Are the x forces canceling? Nope. Which way is the net force? To the right, and what's it going to be equal to? F net equals what? What's the difference between 10 and 9.6? 0.4. Now what's another way you could have found that? You could have gone F net equals ma, m is 0.2, a is 2, 0.4. The net force is 0.4. But the resistive force, which is what they're asking for, is 9.6.